Good morning. Welcome to the Linda Hall Library. I'm Christina Gabordi, Program Manager. Thank you for joining us today for How Do I Become an Engineer? This program is presented in partnership with the University of Missouri, Kansas City School of Science and Engineering. I'd like to give a special thank you to our community partners who participated in the networking hour. American Society of Civil Engineers, Kiewit, Garmin International, Whiting Turner Contracting Company, U.S. Metric Association, and the University of Missouri, Kansas City School of Science and Engineering. Now I would like to thank Marjorie Eisenman, Assistant Dean of Student Affairs at UMKC School of Science and Engineering, and her team for their amazing assistance with today's partnership event. And now I would like to welcome Marjorie to the stage for some brief remarks and to introduce today's moderator. Thank you.
I'm a lot shorter than you. Thank you. Thank you all so much for being here this morning. We're so glad to have you join us and Linda Hall Library. We love our partnership with the library. They're just our next door neighbors. And so it's really great to have this great partnership and this opportunity to bring all of you here today to learn about how to become an engineer. We are really excited to have this amazing panel, and we're going to let them get talking in just a second. As soon as this event is over, the panel part is over, we are going to be doing tours of the school, UMKC School of Science and Engineering. And so if you plan to stay for the tour, just sit tight, and we will get you sent off onto the tour with some of our student leaders. So before I do leave the stage, I do want to introduce our moderator for today, in which we are just so grateful and lucky to have him here. Dr. Eric Timpson is a principal electrical engineer, quality assurance engineering at Honeywell, where he has contributed for over 17 years. He's got a long list of degrees, so get ready for this. He earned his Bachelor of Science in Electrical Engineering with honors, with minors in math, physics, and biology from the University of Missouri at Rolla, a Master of Science in Electrical and Computer Engineering from the University of Missouri at Kansas City, and received his PhD in Electrical and Computer Engineering from the University of Missouri at Columbia. He's like a University of Missouri system mascot. Please welcome Dr. Timpson.
All right, thank you so much. I'm going to adjust this a little bit more here. How about that? Can you guys hear me okay? All right, welcome everybody. We're here for you. And I've got some really tough questions. Just kidding, panelists. I'm grateful to have the panelists, so I do want to start there. So I'm going to hand the mic over here. 1 second. So if you could start with your name, your degree, and where you work, that would be awesome.
Thank you. My name is Danny Hodson. I'm a civil engineer. I work at Wilson & Company, and I graduated here at UMKC in 2021.
I use this? Oh, it works, yeah. My name is Joshua Coney, and I graduated 2021 with my bachelor's here at UMKC and in computer science, and stayed back and graduated in 2023 with my master's here at UMKC. Tells you how much I like it. And I work at Children's Mercy as that part was not asked for, so yeah.
You're good, yeah. You're good.
Check, check. Hello, everyone. I'm Katie Butler. I am a master's student of mechanical engineering here at University of Missouri, Kansas City. I also got my undergraduate in mechanical engineering here as well. I work in Dr. Field's Parachute Aerial Vehicle Systems Laboratory under Missouri Institute for Defense and Energy.
Awesome. Hello, everyone. My name is Tolu Wanimi, Tolu for short. I graduated with my bachelor's in mechanical engineering in 2022, and then my master's in 2023. My emphasis was in manufacturing, and I currently work at a medical device contract manufacturing company as a process engineer / new product introduction engineer there currently. Glad to meet you all.
Good morning, everyone. Thank you for being here. My name is Z Kemp. I just graduated from UMKC in May, so while I'm sharing my experiences, I want to let you all know I'm going to talk about my UMKC experience like it was so far away and long
Yeah.
ago. It wasn't. So, really recent graduate. Right now, I am a civil engineer at Kiewit, and hence I graduated with my civil engineering degree.
Excellent. Well, thank you all. So I warned many of them, but not all of them, so my apologies if I didn't get around. But I like to start with the hardest question, which is probably one that you all have, and that's why. Why did you choose the degree that you did?
Yeah, I chose the degree I did because I wanted whatever I worked on to make a positive impact on the public and the communities that the projects were going to be in. So I think as a civil engineer, we have the unique opportunity to do that. I'm primarily a roadway engineer, so I design roadway systems for cities and states, and everything that I design, when it gets built, people get to drive on it and use it, and it makes a direct impact on the communities that it's built in. So that's really what drew me to the civil engineering profession.
Oh, okay. The scholarship.
Okay, that's
That's one.
a fair answer for sure.
Part of it too is I'm fascinated by technology. I remember really early on when I started, when I got exposed to Python programming. I think it was the most basic of games that you could try, and the way I remember myself describing sort of that experience was my brain was reasoning at ways in ways that I'd never thought of before. I loved it. I loved writing code and then being able to see, that I could make a clock tick or different things. And from then on, I was sort of fascinated by the background, the foreground, the UI, and I don't think that at the time I knew that what I was essentially exploring or the field I was getting into was computer science. I just knew that I liked coding so far, and I liked writing the program, and I liked software. I'm somebody who goes down rabbit holes, and so I remember when I got to try my first computer. This is not like the Bill Gates story, but I do remember the first time when I tried the computer. That was on a Pentium 3 Windows computer, one of those cathode ray boxes, and I think I broke it the first time. It was supposed to be careful about touching it, and the fact that I actually kind of went through the different menus and just kept exploring where it went, and then broke it, and then freaked out, and then fixed it without knowing what I had fixed, which is the general convention with computer science.
Yeah.
If it works, don't touch it. If it doesn't work, just leave it the way it is. But that's sort of how that exploration came about. And then I joke about the scholarship, but that was also the way I got to come into the country and also be able to explore my degree further.
Thank you. Yeah, great story.
Yeah, for me, it wasn't necessarily just one factor that made me choose engineering. I was going back and forth between architecture and engineering. So people in my life, mainly my mom, was encouraging me to go in that direction. But what really sold me on engineering in particular was someone told me at Kiewit that it was like a jack of all trades. You did mechanical. And so at first I did civil because I was in the structural engineering department at Kiewit. And then after that, I saw with what the structural engineers did, and I was like, I don't know, I'm not sure this is my exact topic I want to be under. I liked engineering. I love the people within engineering because I think that's an important thing to kind of keep in mind. But I was like, but what do I actually want to do with engineering? So I went from civil to mechanical and switched over. And mechanical I have really enjoyed because you kind of have a versatile amount of topics you can be under. So I mentioned that I work in the Parachute Aerial Vehicle Systems Laboratory. So we work with unmanned systems. So a lot of robotics, mixture of coding, electrical, different things of that nature. And mechanical engineering was the route that opened up those doors. So it just kind of comes down to what type of skill sets do you know you have, what type of people do you enjoy interacting with, and where do you kind of see yourself being later on. So yeah, just overall people, my own skill sets that I was pointed out by other people, like what that I had, and then just some open doors that were made open to me and I just walked through.
Wonderful, thank you.
Awesome. My typical story is always, my dad is a mechanical engineer, but he works as a technician in a oil company. But every time he would come home, every problem we had at home, he would first attempt to fix it, right? And most he would fix by himself, from car stuff to the house. And I'm like, I want to be able to do anything like this, you know? I want to be able to fix problems that come up physically, because I'm very, very physical in my own makeup. And I started to read a lot of books about people that thought that same way. So my first definition of what I wanted to be was an inventor. I wanted to invent new things, invent new processes, invent new ways, especially gadgets, machines, things that would help people's lives, you know, be better. But then along the line, I decided I want to be a doctor. But that was not good, because at the end of my high school, I decided, okay, doctors they're very, very impressive. I can't do it. For that kind of responsibility is so much in my mind. However, maybe I could make the devices that the doctors use, and that way I can say I save lives too, right? But that led me into deciding I wanted to do medical devices. But I still, like Katie had mentioned, I wanted that flexibility of, what if I end up not really just wanting medical devices? So mechanical engineering was broad enough to where I could hone in at the end of it, which is exactly what I did. I did mechanical engineering, and then by the end of my senior year in my bachelor's, that's when I did medical devices, right? Like medical devices, biomed, all of those stuff. So I went in with that mindset of, I want to be an inventor, I want to help lives, I want to improve the quality of life. And mechanical engineering, being able to physically, you know, do that. People that do coding and electrical engineering, y'all are great, but that abstract thinking wasn't for me, and I am more physical in my disposition. So that's really why, going in, because I wanted to improve life, improve the quality of life.
Yeah.
Do that physically.
Said. Thank you.
Awesome. So for me, I started taking engineering classes whenever I was 14, and having that exposure, having those role models was really, really helpful for me. I think there was also, similar to Katie, a lot of parental encouragement, but also there was just the ability to know that, like, yes, you've got these skill sets that you have, and these are your strengths, and here are careers that mesh well with those. So I had that as kind of my foundation. And I ultimately, as I was going throughout my college experience, you know, I was bouncing around between, I started off as mechanical, actually, and then I was looking at the senior electives, and I was like, there's HVAC, there's other systems, I like dirt. So I switched to civil, because I was looking at the rest of the classes that I would be able to be taking, and it was, you know, water resources and soil mechanics and everything that was very hands-on. And for that reason, I switched to civil. Now I absolutely love it. I also had another component of, I am a very creative person, so I've got a lot of art activities. And as I tell people now, it's a lot easier to be an engineer by day and an artist by night than the other way around. No one wants an engineer by night. Let's just say that. So, yeah, it's just a balance of everything. You know, scholarship also came into consideration, but ultimately it was being able to have a continuous learning process was really, really important for me. I love structure, but I also love change. So it's this beautiful little mesh of, like, what can I have, like, what are the skills that I'm able to build throughout this degree and throughout this starting career, but also something that I'll never be stagnant. I need to always be learning. I need to always be, you know, improving and learning new skills, nurturing new skills. So it was a nice little combination of everything. So that's kind of where I've come to for here.
Thank you so much. Yeah, so next question is, what classes do I need to take in high school to help get the right start for engineering? Or maybe even I talked to a couple people who are already doing some community college classes. So can you give us a window into what classes they should be preparing?
Big one for me was physics. That's really what made me fall in love with civil engineering specifically. The application of math to the real world, and knowing, all right, this equation works out, this is how you can solve for X, and applying that to the real world and seeing the results of the math through physics experiments was really the way that that gap bridged in my mind to learn more about math and science. Another one is drafting classes. So as a civil engineer, what I do from day to day is I draft up plans on the computer that can then be interpreted by contractors and construction companies. And so getting experience with those computer programs that you'll use in your day-to-day world, being able to design and bring things in your head and put them on paper, and using those programs is really beneficial too. So getting those opportunities early on, so that you're not as surprised when you see them in the real world, is a good game changer as well.
Thank you. Any others?
I'll go. I think overall in engineering, coding experience is very vital. There's a lot more coming out, both with the civil, mechanical, and electrical side, where if you can automate the process, you're golden. And so, like sometimes this is required by the company, sometimes this is not. I have a friend who works within Honeywell, and he created his own little automation process of some of the simulations he was doing within his department. And that helps speed up basically his workload. And so I just think having kind of a coding background is helpful, not only for the career outlook later on, but also in the engineering schoolwork as well, because you will come across coding classes no matter which type of engineering department you end up going towards. Then I had a second thought, hands-on experience. So especially for mechanical, tinkering I think is really important. So you're not limited to just classes. If you have any opportunity to like build a little aircraft or just kind of experiment with different things, I think just having that knowledge of how things tangibly fit together makes a big difference, because you're going to be taught a lot of theoretical conceptual ideas. But at the end of the day, do you know how to apply those conceptual ideas to a working model? And more importantly, can you talk and be able to understand the people who are making that model, where they're coming from?
Yeah, I'll piggyback on that. I'll echo that for electrical engineering too. The more you can get your hands on microcontrollers and oscilloscopes and breadboards and putting components together, the more that you can actually physically see the model that it is that you're playing with in math. Yeah. But yeah, you had one. Yeah.
So, wow, it's crazy. Every class that they have mentioned are very important. The classes, I would say, would be a deciding factor as to which specialty you go in or where you should start looking are like chemistry and biology. Because those classes, they kind of start making you think about the everyday things, right? The chemical composition of things that might start making you fall in love with materials and material science. And you start thinking, well, material science, it then splits you up into, I think, maybe three of the more physical engineering. So civil, mechanical, and then you can start looking into architectural engineering. Depending on what's in chemistry you like, you might start knowing what you want to do later on, right? For me, as I said, at the end of my bachelor's, I knew that I wanted to hone in on material science and manufacturing. But I knew that from high school, really, because I liked chemistry. That's not true, I did not like chemistry. I knew that in chemistry, I needed to understand materials if I wanted to know how to select materials for a project or do all those things. And then the biology side is where my love for medicine came about. Yeah. Right? I was able to put two and two together, like, you cannot design something that does not work with the human body, right? Mm-hmm. So you kind of need to know how the anatomy of the body works before you can, think in that direction. So those two classes, in addition to everything, I think are a good balance.
Yeah, excellent. Please.
And I've got two as well. So I grew up in the Kansas City area, so we had Project Lead the Way, or PLTW, as part of our curriculum options. So part of my reasons that I was able to even take engineering classes in 8th grade was part of Project Lead the Way. And so those entire realm of classes, there's engineering, computer science, more of the biology, biomedical. Those opened up so many doors of just learning opportunities for me that I think were really, really impactful. Mm-hmm. And the other one that I think you mentioned was communication. So I was actually a communications minor, and I talk about it a lot because communications minor. And I think that being able to communicate your ideas is such a really, really big key part of your solutions and your workflows, especially if you're automating processes. Well, how are you going to communicate what you did or how to use this tool for others? Within engineering, there's a lot of teamwork, a lot of working in groups, so group projects are also really great opportunities to start to learn, okay, these are my skill sets, what are the skill sets of others, and how can we work best as a team to accomplish our goal? So communication is my big one as well.
That's a really good one. We actually had a whole question on that, right? On soft skills, for sure. So thanks for touching on that.
I think if I were to go essentially answer that, I would probably say all of them.
Yeah.
And the reason I say that is, picking back on, especially what Tolu said was, I remember when we started, sort of like college is going to be 4 years or however long it's going to be, and at some point you're going to specialize. But early on, you have that ability to essentially explore everything. Architecture, communication. One of the things that the engineering school did here very early on was we had these 2 classes called Anchor and Discourse. Discourse was supposed to help you with your communication and essentially your writing. Because at some point, you're going to have to write a grant for something you want to build. At some point, you're going to have to build a business, or you want to build a business, you want to innovate, and you want to write, you want to be able to communicate the way you want, and necessarily not use ChatGPT for that.
Yeah.
You also want to be able to have exposure. So I felt that I was very lucky to be able to take the classes that I was able to take, even with the curriculum that I had.
Yeah.
From sociology to political science to architecture to business, and then you have the student groups too. I think all of those helped me sort of build that emotional intelligence side of it, which you're going to need very, very much further down the line, because like Katie said, if you're designing a product, you're going to be designing it for somebody, and you need to be able to understand the need of that person from their perspective. And so taking those classes really early on, and not necessarily that they're part of your curriculum, but it's more about the fact that they give you that exposure to some of the people that you might end up working, because you might not end up working in the field that you think you're going to be working.
Yeah.
I have a computer science degree, but I ended up at a pediatric hospital. And so like when I think about biology, I'm like, I really should have learned biology. Or chemistry, where you're essentially going into the lab and you need to know what the procedures are. And so that's why I say all of them, because again, at the end of the day, before you graduate, you still need to show proof that you actually completed the curriculum.
Yeah.
So that's going to
Well,
be a given.
Yeah, well-rounded for sure. Yeah, the textbook answer is, calculus and physics are the first courses that you kind of get through, and that's, I was talking to someone in the audience, and he was saying he was already past those, and I said, great, you've already proven intellectual capability. So if you can get through that Calc 1 and that Physics 1 class, especially if you take them at the same time in that first semester, and you've got your study group, then all you got to do is just keep doing that until you get your actual engineering degree. So let's assume that they got it, or they're on the way to get it. Are internships important, and how do they get one?
People. I would say connecting is going to be your biggest friend. You can apply to as many jobs as you want to, but most of the time it's going to be someone you know or someone you know who knows someone else.
Sorry to interrupt you. You're saying they have to talk to people.
Yes, I know,
Do
crazy.
you know what year it is? Do you know we have telephones
And
that you can just watch endlessly?
Well, and it's crazy. I will
just
say
kidding, yeah.
COVID,
Yeah.
the COVID time did kind of wreck a lot of people in that way, okay? Even if you were a natural communicator, you were spent in kind of this isolated environment. And then all of a sudden, hey, go out, do hard engineering things, and then also try to talk to people, figure out what you're gonna do. It's a lot all at once, especially if you're kind of a detail-oriented or just an analytical processor. But I would say the biggest advice is just do something, just talk to someone. Little by little, you'll become better at communicating, at those engineering skills. And go to events that you don't necessarily think that you're like, oh, okay, maybe this could be interesting, but could be nothing. Go to them anyways. When I started working at MIDE, I didn't know that MIDE even existed at UMKC. What it was is they had a Johns Hopkins seminar, and I was like, that seems different, and I almost didn't go. And then I showed up, and then my boss, now boss, was like, who are you? And then I got the job. So it's like, just show up, and you never know what could happen once you just take that first step forward.
Yeah, or like today, right? Like you could ask the booths and the people here, like, are you offering internships? For sure.
Yeah. Okay, go on.
Yeah, internships are huge for a lot of the reasons that we've already brought up too. These degree programs are very broad, and once you graduate and start working in the real world, you're more specialized. And so I always say internships are a great opportunity to figure out what you like. And it's also a great opportunity to figure out what you don't like. Civil engineering is very broad. I knew a lot of people who got an their first internship. Beggars can't be choosers. They got an internship in a field that maybe they were a little interested in, but it wasn't their number one choice. And then after the summer, they were like, great opportunity, glad I can put it on my resume, but now I know that I really don't like structural as much as I thought. So it's a good opportunity to explore in that way. And then like Katie mentioned, I always tell college students to apply for internships that you might not think you're qualified for, but have them make them tell you no. Apply all the internships that are out there, and if you're not qualified for it, make them tell you no and put yourself out there. Because even if you don't get your first internship, you've interviewed and you have explored the opportunities out there, and so when the next one comes, you'll already have that experience under your belt of this is how you apply, this is how I can make my resume look as best as possible, and this is how sitting in an interview feels, and so that when the next opportunity comes, you've already kind of been there. So yeah, internships very important, and I think all of us are UMKC grads. Being here in Kansas City, where the jobs are, where the professionals are, sets you apart from some of the other universities in the area. If you're, no shade on KU or MU, but there's more jobs here in Kansas City than there are in Lawrence and Columbia. And so the proximity of being here in Kansas City, where the jobs and the professionals are, gives you those connection points. Because I'm here on behalf of ASCE. There's a big Kansas City chapter. There's a lot of professionals in Kansas City who came to UMKC to mentor us and to talk with us. It's a lot easier to do if you're here in Kansas City than if you're at other of these state schools. And so just the proximity of the internships and the jobs can set you apart as well. So, yeah.
Yeah, I think you mentioned something so important about not necessarily being very picky. One of the things that have prevented a lot of people from pursuing internships is that strive for perfection. They want the one that they want to end up in.
Yeah.
And you might be lucky, and it might be the case. I work in medical device contract manufacturing, which is where I didn't know that was exactly what I wanted to do. I thought I was going to be making robotic surgical equipment. But that's where I am now. But my first internship was as a project management intern at a construction company. And it didn't make sense to even take that because I knew from the beginning I wanted to do hands-on medical, components and machines. But I took that opportunity, which by the way, was in my third year of college. So this is after 2 years of crying, I don't have any internship. There's no one who likes me,
Yeah.
But that third year, I saw an email, which from UMKC, they do a good job of, keeping this community of newsletters, opportunities, internship opportunities. Like Katie had mentioned, you might see a workshop and you might see a seminar somewhere. I saw an email that said a scholarship opportunity, and I'm like, I've not gotten any other scholarships apart from the ones I get. I don't have good luck with these things. But I applied anyways. And it's so interesting because I don't even think I got the scholarship. But in the moment I finished applying, I went through the page and I saw, this was 2021 maybe. 2021 internship opportunity. I'm like, and I applied and I knew, again, it wasn't exactly what I wanted, but I got that from there. And that was it. I got the interview and it was a great experience. I learned project management. Yeah. I learned what it means to be quality conscious. I actually traveled to Atlanta for the internship and they sponsored everything and it was really, really good. I got a lot of skill sets from that. I'm not in construction, but I learned a lot. But internships are important because they add to your experience. You can add all the organizations and these other involvement opportunities you have in the community, and those are also important, and I'm sure we'll talk about it too. But when a recruiter or a manager is looking for a reason to hire you, they're looking for your professional experience. And internships, thankfully, count towards that. So no matter how small, they can at least look at your experience and say, well, they were accountable to someone and they had to show up on time for something. So that means here they will be accountable and they will show up. So that removes that ambiguity, right? So I think that's one of the most important things I can add.
Thank you. Yeah, so there's just a couple things I want to foot stomp, and also looking at the time, I know that you guys are all going to have questions too. So start to think about some of those questions, and after we make a couple points here, we'll walk around with microphones to make sure that we can get your relevant questions. The first one was what you were saying, Danny, which is how many opportunities are in the Kansas City area? You know, I was talking to someone about, you know, Burns and Mac and Black and Veatch, and thinking all the way back to when I was surviving as a student with a study group, right? Because the importance of a study group cannot be understated. Like, you got to find your study group, you got to find who you can do calculus and physics with and struggle on those problems. You fast forward 2 decades, now I've got buddies at Black and Veatch. Now I've got buddies at Burns and McDonald's. They're, you know, directors. I've got friends in medical industries. T-Mobile is where I did a lot of my internships, and so still have plenty of a network over there. And so what's cool is not only do you get to struggle with calculus and physics like right now, or like, you know, you're on the precipice of this, but then you get to keep those people relationships that we talked about for the rest of your life. And in the Kansas City area, there's just so many awesome engineering opportunities. That's yet another reason to become an engineer, for sure. So looking around, do I see any questions? Oh, yay, we got one back there. Thank you.
Head in your way.
What, I guess, what are the pathways to become an engineer?
Yeah.
What kinds of internships are you looking to get to facilitate being able to pursue a specific kind of engineering? How do you ensure that you have a diverse I guess,
Experience set.
profile?
Yeah, definitely. So let me just summarize it for you real quick. So, you know, in high school, obviously you want to finish with your high school diploma so that way you can get accepted into an awesome school like UMKC. Then once you're in UMKC, those first 2 years, you really focus on the calculus and the physics. You know, so Calc 1, 2, 3, Physics 1, 2, and if you're a chemical or a biological engineer, you'll be taking those chemistry and biology classes. The last 2 years are where you typically specialize. So that's where an electrical engineer would take more circuits and power and more advanced mathematics in order to do time and frequency conversions, whereas a mechanical engineer is going to be doing more things like thermodynamics and understanding the transfer of energy in the universe. And so after those last 2 years, believe it or not, those 4 years go very, very quickly. Well, I should say during that time, hopefully during the summers, you've met some people and had some internships and applied to some places, and you built your network, and you've actually studied. What does Burns and Mac do? What does Black and Veatch do? What are these? What does Garmin do? Or is it only fish finders, or is it more than that? And you can learn about all that stuff from your network, and then you apply, and then you do your job interview, and then hopefully they say you accept. And so that leads me to the second point that I was going to make, which was, in short, you miss 100% of the shots you don't take. So, you know, don't be discouraged when you apply to a place and you don't hear anything back, whether that's an internship or full-time or anything. Yeah, another question there.
Head in your way.
So we're talking about like networking and that type of stuff. Besides like LinkedIn and like those sort of social platforms, is there any secret engineer hub where you guys like all gather on like a singular app where we can find you all, or is it just LinkedIn?
That's an idea. That's a good idea.
Yeah, that actually.
Look, we should launch that out.
I was just saying, you might have just invented that.
So I don't think these are fighting words, but computer science is also engineering.
Oh, yeah, no, that's
It's,
not fighting. Yeah.
I remember very early on when my friend and I, he was like, "You're not an engineer." We're not an engineer. We took it to our professors. Engineer, not engineer. Well, let the community decide. But computer science, for each of the courses that we were taking, some students decided to open a Discord channel. And Discord was sort of like this really nice way for you to connect with other students who were in that same class. And you could ask questions and get help with different things. It was also helpful when you had like end of year projects. And at some point, I think one of my favorite memories is my last senior project capstone, where we had a Discord channel. Teachers are not usually on Discord channels, so like that really keeps it very free for you to be able to, talk about the courses and rate the professors if you want to. But then we had a professor who actually was part of the Discord channel, and he would get on, and we called him King Bing because he was. It was really a fun thing, and then he would get to see sort of like where we were, and like it was very structured too. Think about like teams when you're using in a corporate setting. So Discord is one of those places that you're doing. But the other part that we might have touched on or mentioned was student groups. UMKC has over 300 student organizations, and it seems like just a number putting it out there, but I will say, like you mentioned ASE, and there are lots of student organizations within each school at UMKC that if you get to tap into, that sort of opens you up and exposes you to those opportunities that you're talking about, which when you get them, you have to seize on them.
Yeah, that's a great question. Actually, in fact, Ricky and I were talking about that earlier today. Were any of you guys on a design team? Yeah, would you want to just talk a little bit about it, or yeah?
I was not on design team, but I have experience founding a student organization. So that's a big point that I wanted to make of if there is throughout those 300 plus organizations and you don't find something that suits your fancy, make one. It takes like 10 people and yourself.
Yeah, that's really good advice.
Yeah, I think on that note, like to answer both questions actually, you can think about it as, on the first question, you could think about it as the moment you decide to go into engineering, the content that you should seek is engineering related content, math, hard things, innovative things. Start to structure your YouTube algorithm to be like, fix up things, stuff like that. Because we already are charged around with, from social media and everything. So you can feed your mind, feed your brain with the information that would actually then decide or make you decide whether you want to do it or not, right? So in terms of what pathways you can use, on that first note, just do hard things, look up hard concepts, try to understand them. If you struggle with it, actually allow that process to be completed. Struggle with it, Let the problem reveal itself to you gradually. Look up, spend weeks if you need to on a problem, spend weeks if you need to on a project. Start something that you think would be fun. Start a robotics project. I'm done with school now, but I still work on CAD design projects for freelance purposes. But I allow yourself to learn new things, and in learning new things, you would at your stage now, you would decide what path you want to then take. You might fall in love more with robotics or fall in love more with CAD design for different things. And then on the secret engineering society, yes, there are 3. I'm kidding.
But he can't tell you what they are.
I can't tell you.
See me after.
But organizations on campus, like they help a lot. There are, large engineering bodies like ASME, ASCI. They have all these acronyms. But there are organizations that allow you to subscribe to a newsletter, and you can learn new things every other day through emails. Like Joshua had mentioned, there is Discord, but there's also just joining a large organization, like an organization that has a chapter on the campus, but also is nationally recognized, right? Because then you are basically connected to that body that maybe they control the new regulations in that field. You know, they talk about, how do we want to fix this problem because this bridge collapsed. So now we have to discuss how we want to, you know, set the rules so that other engineers don't make the same mistake.
Yeah, well
There's so
said.
many organizations like that.
Yeah, in fact, it wasn't obvious at first, but IEEE for electrical engineers is the world's largest professional organization. So if IEEE, IEEE, AIAA is another large professional association for basically rocket scientists. So the more that you can kind of get into those circles, like I had a flashback when I was an undergraduate, wrote a paper on photodiode network controllers, kind of like, you know, on a whim or whatever, and submitted it to an IEEE and got like a student scholarship and stuff like that. So. So there are not secret but very real and loud professional engineering societies that you can get acquainted with. Yeah.
Quick answer too. A simple answer to both those questions too is that UMKC has what's called career fairs in the fall and the spring, where over 50, 60 companies come to campus, set up a table much like this morning to get in front of the students. And so that's also one of the easier opportunities to learn about the companies in the Kansas City area, because all these companies come to campus to get in front of the students so that the students can learn about them. So that's a good opportunity to learn about jobs and companies in the area as well. So.
Yeah, definitely.
Research is another one. UMKC is, if you look outside, you'd see that UMKC is an R1 university. I want to say it's a prestigious award for a university to have.
Yeah.
And that has to do with the investment in research that you do. So one of the things that, looking back now, that I wish I did a lot more was go into research opportunities. So whatever students would get to present their research at the library, it was always on the walk path for students when you were going into the library to study and you walk by. And you'd walk and you'd see all these amazing research that some students were doing. It could be in any field. And a lot of times people would just walk by. You wouldn't stop to sort of like figure out what it was. I now realize that it would have been very important to be able to spend time, talk to some of those students, what it takes to get into research. I mean, we're right here at Stowers. Yeah. So there's a lot that goes into research, and that really exposes you to a lot of things that you're talking about opportunity. You can be able to go to conferences as part of your research if you end up with a PI. You don't necessarily have to stay in it, but then the fact that you get to essentially explore something. We're talking about starting an organization if you don't see an organization that fits you.
Yeah.
You could essentially start a new field of research that does not exist, and then with the resources that the school has or does not, you can be able to start a new branch in a specific discipline that takes you more than
Yeah, I would
Very
kind of
well.
actually like to add on to that. So kind of summarizing what everyone here has kind of talked about, getting involved in different organizations. So we have like the civil engineering, the mechanical engineering, the IEEE, AIAA, which is like the rocket science stuff. So some friends and I, we started Design, Build, Fly engineering competition team. We didn't have, in what that is, just for kind of a quick context, that's when you design, build, and then fly in Tucson or Wichita your own little aircraft. And so originally, UMKC didn't have any of that. Like, we don't have aerospace majors or any of those classes, and we have a couple senior design classes, but that's about it. But some friends and I were like, this would be kind of cool. Let's just do it. But then you're left with the question again with the networking, like, how do I start? Well, for us, it was talking to other staffs, other professional engineers, because where you fall short on technical knowledge or connections, typically someone else can help you out. And so I would say getting involved with organizations, so you can go to conferences, research, also to go to conferences, and meet other people who are outside of your locational bubble and also professional bubble. And then from there, it just takes intentionality and time. There's no secret recipe, but
Yeah.
if you just continually invest in time and in different people, other things will pop up.
Yeah, well said. So let me revise my timeline, right? Is like, so the first 2 years, calculus, physics, second 2 years, you're specializing in something. You could have gotten an internship, and with just a bachelor's in engineering, you take the FE exam and then the PE exam, and then you can be a licensed professional engineer in the state of Missouri, at least. Different states have other rules. And there's other like researchy like paths. So in other words, you could be writing those papers, going to those conferences, talking to more people about the research that was funded, about the research that's not funded, that's in your own imagination that you want to get funded, and you could become an engineer in that way as well. So looking around, do we see?
Got one in the back?
Yay, yes, please.
What kind of
Remember.
what kind of courses in engineering would you need to use for like designing roller coasters or amusement park rides?
Ooh, that's a good question.
Oh, okay.
Well, so statics and dynamics is your first one. You're going to need to know that. And then, well, again, physics at first is where you start to learn
Everything.
how do I apply the math in order to make these predictions about reality, whether that be you in a cart on a chunk of metal in a hoop, right? And it's like you want to make sure that's safe, and that's what engineers' job really is, right? Is when I stamp a drawing at the end of the day, I say that that's available for public use because I've done the equations and I know that it'll be able to withstand whatever loads that it has to go under.
Yeah, everything first has to make sense on paper, and the calculations have to make sense. So all the classes from the statics, physics, dynamics, strength of materials, those classes are very important once you're in college. Material science also is huge because even I still think, how is that working?
Yeah, right?
Nothing's breaking, Material science, material selection, those are classes that they get you in that thinking frame point of, steel is strong, but I want some parts of it to be light. So aluminum, this, you can think about some other things once you have a holistic understanding of materials, right? So those classes are good. I will say because of the moving parts in a roller coaster, the classes that have to do with robotics as well makes sense because you would have to have a gearbox and I guess the robotic portion of that whole system. I want to say mechatronics and machine design, just because in machine design they teach you about gears, bearings. Machine design definitely. Bearings and like everything that makes the machine actually make sense to actually.
And actually you can illustrate it right here as all of the engineers could have something to do with that roller coaster, right?
Yeah.
So like some of the roller coasters are electromagnetically powered. So those ones you're going to need the electrical engineer for. Other ones are going to be pneumatically powered. So the mechanical engineer is going to be studying how do I store up all that gas in order to release it quickly. The chemical engineers are going to be working on the rubbers, foams, films, plastics that go into making all the little parts of it. The civil engineers, again, they're going to be trying to figure out not only is it safe, but like the crowds. How do we get the crowds in and out? I mean, there's so it kind of reminds me of a game, right? It's like when you're playing a game to build roller coasters, whether you know it or not, you're actually kind of being an engineer. So
I mean, you could start with a little Raspberry Pi design.
yeah, there you go. That's
Because
fun.
it essentially illustrates all the components that go into it. The battery part of it, you need to figure out just the voltage, the right one to use. You need to map out your route. You need to do some coding in it. You need to figure out the temperature. You need to be able to be sure that you have it in the right setting. So that's, if you're talking about a course or like a game, that's something that you could just, get. I don't know how many people still use Raspberry Pis, but they're like,
Well,
They're still around for sure.
And I think it's important to mention too, whenever you're considering any type of niche field, whether it's roller coaster or something more like aerospacey, the biggest thing is you're gonna take these classes through like, your own exploration and like different little plans you make for yourself. But early on, even when you start college, look up on LinkedIn what companies actually do these like projects that you're interested in and cold message them. I mean, you'll be surprised how many people will actually respond. And you don't have to like, make it a whole big thing. You're like, just be curious, right? Say, hey, this is where I'm at. I am interested in this because of whatever reasons. Would you be willing for me to shadow you on this day? Or you never know what could happen from that. And that's gonna be your key factor because your classes will come naturally, but you really just want to get more experience and get to know those people who are in those areas, especially the niche ones.
Yeah, that's a great one. And that combo of friends and family, what do you know about this company? And then compare that with your own research that you've done on the internet and kind of connect those dots. Yeah,
We've got one in the back of the room.
Okay, we got one in the front too. So I think we're up to 3 and we're doing good. We got 9 minutes. Let's do it.
So, hi, I'm currently a junior in high school, so I was wondering, you've talked a lot about like calculus and physics, but outside of like classes you can take in high school, what else can you do like outside of school?
Yeah, that's a good one. I'll start real quick. Calculus itself is like 70% algebra, 20% trigonometry, and 10% calculus. So the more of those like pre-calculus and those algebra classes and stuff that you can do, the better. Any thoughts on that one?
Yeah.
Are you in the Kansas City area?
Yeah.
Okay. I don't want to be
Project Lead the Way.
Project Lead the
There
Way.
it is. That's a
there's
good one.
KC STEM Alliance.
Yes.
And then there's also like First Robotics. There's a lot. There's Kansas City, like SWE Next, so Society of Women Engineers Next. They've, at least whenever I was in high school, they had different like student chapters. So there are people out there. There are opportunities. It's just a matter of getting out there and getting your foot in the door and talking to people.
Yes. Thank you. Yeah, let's hear this
Great,
one.
up at the front.
Hi. I have a question about the two tests you just mentioned, FE and PE.
Yeah.
Yeah. Do the computer science have this opportunity to take these two tests too?
Yeah, that's a good question. So if the computer scientist, so in electrical engineering, the discipline gets a little interesting is the short answer. I'm just going to ask him, did you take the
So this is that part where like we consider computer scientists to be engineers, up to the part where you have to take the exam.
no, he didn't.
Well,
yeah.
like, we all mentioned sort of like the different organizations that are out there, IEEE, the more standard ones. Computer science has ACM. Not a lot of computer scientists actually know about that. But the discipline of computer science sort of I'll describe it as an umbrella where essentially you can start getting into specific fields, software engineering, cybersecurity, all of that.
Yeah.
Not all of them have an exam that you have to take. And there's this back and forth about, the requirements that computer scientists have to or don't have to compared to like engineers. Computer scientists don't have the same exam that, and the other branches of engineers have to spend sleepless nights trying to figure out. Because with computer science, you get it working, and then you hope that there's an ethics committee that is going to approve it. Obviously, you have to be good at what you do, and then when you get into specializing fields like cybersecurity, there are going to be some exams that you need to take before you graduate. But I don't want to say that there's no exam, but there's kind of like no.
It is discipline dependent.
Yes.
And he talked about it as an umbrella. I like to talk about engineering itself as an hourglass, which is when you first say, I want to be an engineer, that's like, I want to use math and science to help people. So it starts really big. Then you get to school and they're like, what type? Gets really small in the middle there. They're like, you want electrical, you want mechanical, you want chemical. And that's because, again, those coursework are going to focus on that, and that, like, how specifically do you want to apply science and technology to help somebody? And then guess what? You get a job. And I'm like, hey, welcome, day one. I know you're a mechanical engineer, but here's a chemical engineering part that I need you to run. So it goes big again back at the top. All that said, there are legal requirements why you do need engineers to work on projects. Civil engineering is a very, very real example of that. And so if you need to stamp a drawing that's going to hold up in court, that's when you need those two classes. The biomechanical area, the law, it's new, and so the law is kind of new there on whether or not the electrical engineer, for instance, associated with that project, or the computer scientist associated with that project, really needs to stamp it or not. And again, with AI, I'm sure it's only going to get even more interesting.
And so I'm glad you brought that up, because I think, especially with the AI, there are going to be, and there's an effort to try to do that, because AI essentially spreads into different disciplines.
Yep.
I'll say, in addition to you saying it's also discipline dependent, it's also job dependent.
Yeah.
So working at a pediatric hospital, for example, you're going to be working with people, And when that ends up being the case, there are specific trainings that you have to take certifications. CD trainings, for example, that can essentially, it's for different ones, they're about 3 years, 5 years ones, and you can take them to different organizations that you're working at. So it is discipline dependent, but it's also job dependent, whichever one you end up in.
Okay,
We got another one in the middle.
Yeah.
How does engineering interface with other fields, and how do you use other fields in your work?
I can start because
Yeah, that's a good one.
there's something about
A hospital?
So the first thing that you have to understand is even after you become an engineer, it's not done. That's not the end.
Amen.
There's still other things in life, right?
Continuing education.
And
going back to that.
in medical devices, I've had to teach myself a lot of things about regulatory, the FDA, ISO standards, so many things that I never even thought existed. But in a company like a product design or product manufacturing, you're just one piece of the puzzle, right? So you kind of have to learn a little bit of every other thing. For example, I don't design medical devices at my company. I design the processes for manufacturing, and I take that manufacturing process onto scalability. But when I function as a new product introduction engineer, higher up the design chain, I'm thinking, okay, we've made an enclosure box, right? But an electrical engineer is going to design the circuitry inside the box. I have to start thinking, what space do they need? How much room do they need in that box? But I need to understand a little bit of electrical engineering, only as much as I need to. When it then comes to computer, I'm thinking, okay, in medical devices, you have to be cybersecurity conscious as well. So believe it or not, even having a USB port at the back of your device is one way to help the cybersecurity engineer say, okay, I'm thinking about all the things at the back end. We have a USB port that is also covered and all these things. So you have to have a working knowledge of all the different fields. That's why you kind of keep learning anyways. Even if it is knowledge that you think is not applicable to you, just read it, just look at it, just listen to that video, listen to that audio, and keep it pushing. But in your company, as you grow, the teams that you become a part of, be aware of what the other team members are doing, right? Be hyper-focused on what your deliverables are, what you're supposed to do, but have an understanding of what everyone else is doing. In any team, it may not even be an engineering team. It might just be whatever project you find yourself in. But that ability to learn, additional knowledge to what you do is a very good skill, because you will see that in real life. In my company, right now, the kind of understanding of risk management and medical device regulations I have, it's amazing because I didn't go to school for that, right? But that's it's your due diligence as an engineer. The reason why you're an engineer, first of all, to improve the quality of life of other people, but it's also because you like to learn. So you have to like to learn, and you have to be willing to learn hard things. But the moment you say, I'm going to learn hard things now look really, really simple, because it's like, tomorrow is another hard thing I'm going to learn. And then hard things become watered down. It's like, oh, that wasn't so hard, So give yourself that room to learn hard things every day, and just know that you will need to learn new things every day.
Snap for that.
Yes, touching on that is learn to fail and constructively fail.
Yeah.
School is the place to fail, and it's okay. Coming from a perfectionist, it's okay to fail. So you learn more from your failures than you do your successes. You succeed, you're like, yes, I turned in this project. I don't know how I did it, but it works and it's great. But then if you fail, you're like, oh, wait a second. Oh, I messed up here. That impacted this. And you're able to trace your steps and learn from that process. So fail constructively. It's also a skill that you nurture.
Heck, I mean, even in research, I would say most of the things that happen are not necessarily successes. Like, failures are your stepping stones that eventually lead you to an inch of innovation. And so it just kind of depends where you're at. Sometimes if you're more of a corporation, it may be a little faster, but you also have the similar design processes where you have to kind of go over iteration by iteration and see what actually fits collectively between interdisciplinary teams.
I mean, she mentions failure, and I'm sure if you asked each person on this table, they probably have, like myself, a folder of rejection over
Oh,
the
yeah.
years.
Yeah.
But just to add on to that too, using that example of the roller coaster, a roller coaster can't be built by just one discipline.
Yeah.
You have to talk about like the risk management. You have to talk about funding. How do you get the funding? How do you make sure that you deliver it on time? You get a project manager. How do you make sure that you actually attract people to come actually see that it's safe and then do it? You could talk about social media,
marketing.
influencers, marketing, and so that's a small way where you start seeing all the different branches essentially start working together. Because again, like the word he said, a part of a puzzle. You could be the brains behind, and I like to think of the streetcar, for example. If you're ever on the streetcar that we have now, just take a moment to sort of reflect on like the different disciplines that essentially went into like the different backgrounds that would have had to get it working, where it is, have the wires going overboard, making sure that it is actually on time, making sure that the timing it shows, if it says it's 4 minutes, it's not showing up 15 minutes later. And that's, the really
Well said. Yeah, and so to take us all the way back to the beginning and closing now is, one of the reasons why I chose engineering is because you don't have to go into engineering. It just means you can do anything at that point, right? Because it's such a difficult degree program with the calculus and the physics that so many people say no to it, that it really does create a very special niche for you in the universe. Like Weird Al Yankovic, for instance, is a pop culture singer. He's actually an aerospace engineer by degree. So we want to thank the panelists again very much. Appreciate you guys. Thank you all for joining us today. And I think we're going to turn it over for the tour now.
Yeah, thank you, Eric, for moderating this amazing discussion. And thank you to the panelists, and thank you all for coming out to the library this morning. Keep a lookout on lindahall.org. We've got so many amazing programs and events, especially lined up for 2026. So please check back. And now Marjorie will get the tour kicked off.
Thank you. Thank you again. I'm so proud. These are all have been students while I have been at UMKC, so I love seeing them up there. It just is like, it's like a mom heart for me. So we hope that you will be able to join us for a tour to just right across the way to the School of Science and Engineering. So if you have a gold star on your name tag, who's our first group? Angel is our first tour leader. So if you have a yellow gold star, head on back to the back with all your stuff to go meet with Angel.
Thanks.